In this lesson, we're going to look at radicals and rational exponents. And in the first part, which is this video, we're going to practice converting between the two forms. We'll also do some very simple evaluating. So our question is, what are radicals and rational exponents and how do they relate? So to understand this, we're going to begin by looking at these right here. These are known as radicals. You know this one as the square root sign, but there's more than just square roots, there's other type of roots. So a radical is an expression involving an nth root, where n is an integer. So this is read as the square root of a, the sixth root of a, the cube root of a, you could say the third root of a, but typically we say the cube root of a, and then just in general, this is the nth root of a. I will tell you that the root is known as the index. Okay, so the index on the square root of a would be a 2. Okay, so let's simplify the cube root of 8. What this means by definition is we're looking for something that when I multiply it by itself 3 times, I would get 8. And since that 2 times 2 times 2 is equal to 8, the cube root of 8 is 2. The sixth root of 64. Well, again, I'm going to start with 2 because numbers get really big. If that's not right, then I'll try 4. All right, so 2 times 2 times 2 is 8. Well, 3 more 2s would be another 8, and 8 times 8 is 64. So 2 to the 6 is 64. Therefore, the sixth root of 64 is 2. The fourth root of 81. So since this is odd, I'm going to try an odd value. I'm going to try 3 times 3 is 9, times 3 is 27, times another 3 is 81. Therefore, the fourth root of 81 is equal to 3. All right, now we're going to look at rational exponents. A rational exponent is an exponent that is a fraction. So sometimes these are called fractional exponents. In class, I say rational rhymes with fractional to help you remember. So this is a to the 1/2 power, a to the 1/6, a to the 1/3, and a to the 1/nth power. So I want you to evaluate each of these. So you can type this into your calculator just as is, 8 to the 1/3 power. If you have an older graphing calculator, you would do 8 caret, and I always put my fractions in parentheses like this. If you have the newer calculators, it will automatically move your exponent up into the exponent spot, and you would do 1/3, right? You'll get 2. Try 64 to the 1/6, and also try 84 to the 1/4. I get 2, and I get 3. Well, what do you notice here? Okay, I'm hoping that if you compare it to what we did over here, check it out. Cube root of 8 is 2, and 8 to the 1/3 is 2. Look at the next one. Sixth root of 64, and 64 to the 1/6. And then lastly, the fourth root of 81, and 84 to the 1/4. Okay, so they got a lot of the same numbers. So what is happening here is that the ones I highlighted in the same color, they're identical. So the cube root of 8 is the same thing as 8 to the 1/3. The sixth root of 64 is the same as 64 to the 1/6 power. So in general, to convert a radical form to a rational exponent form, I'm actually going to start on the right side here with my rational exponent. And I'm going to put some letters in here, and I'm going to use an E and an I. And I always have a reason why. Exponent over index is what that stands for. And how on earth are you going to remember EI? Well, how about Old MacDonald had a farm? E-I-E-I-O. Okay, so E over I. E stands for exponent. Well, where's the exponent over here? It's this value. Okay, so E goes right here, and I is the index. And I'm just going to remind you, index and index. And then This is my exponent and exponent. E-I-E-I-O. Okay, if you learn that, I think it will help you convert between our two forms. So here I have a table that we're going to try to complete. It says the expression should be written in radical form, rational exponent form, and evaluated like the example below. Fill in all the missing pieces. So this is the 4th root of 16. 4 is the index, so notice it goes in the index spot. What's the exponent on 16? It's 1, so that goes on the top. So 16 to the 1/4 power is 2, okay? Because again, 2 multiplied by itself 4 times is equal to 16. All right, the next one, the cube root of 343. That's the same as 343 to the 1/3 power. Type that in your calculator and you should get 7. Now is a good time to also tell you how you can enter the cube root of 343 in the calculator. If you hit the math button and select option 5 right here, this will help you enter any index. You'll just move your cursor where the X is. You may notice above it, there's just a button right for the cube root. So if you're asked cube root, you could use option 4. Option 5's for all roots. Okay, so 1,953,125 to the 1/9 power. Well, exponent over index. I'm just going to zoom in a little bit here. This would be the 9th root as my index. That's a little sloppy. The 9th root of 1,953,125. Exponent is 1 to the 1st power. Now, I wouldn't need to even write that 1, so it's just the 9th root of it. And I notice it ends in a 5. I bet it's probably 5 to the 9th, but you can type it in either form of your calculator, whichever is quicker for you. And yep, sure enough, it's 5. Okay, 8 to the negative 1/3. So first of all, I'm going to do something a little extra here. So I know a negative exponent is actually a fraction. So this is 1 over 8 to the 1/3 power. Okay, so what is this as a radical? It would be 1 over EI. I'm going to make my cube root. My index is 3. And 8 is my radical. And of course, it would be to the 1st power. I don't need to write that. So what does that evaluate to? Again, you can put it in your calculator. Or I hope you know the cube root of 8 is 2, because 2 to the 3rd is 8. So this is going to be 1/2. Okay, the next one, 27x to the 5/4. Okay, let's write it in radical form. I'm going to draw my radical, my, again, exponent over index. So 4 is my index, and 27x to the 5th, and written like this, it's wrong. I did that to intentionally point out that my base is more than just one number, so I need to make sure that I have parentheses around my base. Now, to evaluate that, it has a variable, so we're not going to evaluate this one. Number 5, negative 125 to the 1/3 power. So this is exponent over index. So again, zoom in here, the cube root. Now, notice sometimes I do a little better job of keeping it like inside here to really show it's an index. It's a good idea to do it like that. The cube root of negative 125 to the 1st power. So I don't need to write that 1. So you might pause for a second and go, can I take the cube root of a negative value? Well, try it on your calculator, and sure enough, you get negative 5. And why is that? Because if you think about it, negative 5 times negative 5 is a positive 25, times another negative 5 is negative 125. So, yep, cube root of negative 125 is negative 5. All right, the square root of negative 400, square root. Okay, so my index is 2, my exponent is 1, so this is negative 400 to the 1/2, exponent over index, but because it's more than just a number, I got to make sure I put the base in parentheses. Okay, so if it's just a positive number, you don't need the parentheses. But if it's a negative number or if it has a variable attached, you absolutely have to have parentheses around your base. Now this one, what's the square root of a negative value? Well, this is non-real, okay? So we're going to just go back. We're not going to deal with imaginary numbers when we're dealing with higher roots. Might feel like we're taking a step back, but it should actually make things a little bit easier for you. Okay. So what's that mean for us right here? When we're taking odd roots, okay? If I have an odd, meaning my index is an odd number, a 5, these are all 5s, or if it's a 3, or a 7, or a 9, okay? If you're taking an odd root, we got to watch for some things. When we're finding all the roots of odd functions, there's only ever going to be one solution, okay? So if you're taking the odd root of a positive number, you're going to get a positive value. Odd root of a negative value, you're going to get a negative answer. Odd root of 0, you're going to get, again, one answer is going to be 0. It's with even roots that things are weird. And when I say even, I mean square root, 4th root, 6th root, 8th root. I'm talking about the index out front. Okay, so if I ask you for the 4th root of 256, it's 2, but it's also -2 because a negative times a negative 4 times would produce a positive. Whereas if I take the 4th root of a negative value, I can't do that in the real number system. There's no solution here. The 4th root of 0 is going to have just one answer, okay? So if it's odd, you are going to be able to, if it's odd and the radicand is negative, you are going to get a solution. So let's see if we can evaluate these over here. The cube, so first of all, I notice it's odd, okay? Odd index of 3 and a negative radicand. Can I do it? Yep, I'm going to have one solution. So I would like you to type this into your calculator. Please do it with me. Don't just watch me because you got to practice getting things in the right spot on your calculator, and I get -8. All right, the 6th root of -4096. Okay, so this is even. This one's going to have no solution or be non-real, we could also say, all right? When I say no solution, it's really when we're solving equations, and these are just expressions, which is why I'm saying non-real. All right. The next one, 4 to the 1/2. Well, I know that that's the same as the square root of 4, and then that negative sign is out front. It's not inside with the base. So the square root of 4 is 2, and then I just bring this negative over. It's still chilling with it, so that's -2 for my answer. Now look at how that differs from my next one. This time it's inside, okay? So this is equivalent to, my index would be 2, the square root of -4 on the inside, exponents 1. I can't do this. This one's non-real. Okay, now we've learned with imaginary numbers, we could define that one as 2i, but non-real solution if we were solving an equation. The next one, okay, so I look at my index, it's a 7. That's odd, and I have a negative radicand, okay, so I am going to be able to do that. So I'm going to type this in my calculator, and what I know is going to happen is there's going to be this negative that's out front, and then I'm going to get a negative answer here, which is going to switch everything to positive, and it's 4. And a negative times a negative is a +4, okay? But really, if you were using a calculator, you could type it in the calculator exactly as you see it there. It's good to understand what's happening. Okay, the opposite of -8 to the 1/3. Okay, so what's this equivalent to? I'd have a negative on the outside. I draw my radical sign. That would be the cube root of -8. Well, first of all, the cube root of -8 is going to be -2. Then I've got this negative sign chilling out front, and negative times a negative is a +2. Okay, so you're going to be doing some practice converting between the two forms. So it's your turn to check. I have two problems on the screen. I want you to change both of these to radical form. Hit play when you're ready to check your answers. So the first one, exponent over index, would be the cube root of 23x because it is more than just one value. It's a product. I'm going to group it together, and the exponent is 2. The second one, 4 to the 1/2. This is the index is 2. I don't write it. It's understood to be the square root of 4. And again, for the first, I would not need to write. We're going to convert each of the ones we see on the screen to simple radical form. So exponent over index. So here's my exponent, and this one's my index. So keep your base as you see it in parentheses, negative 2x to the 3/4 power. The next one, the index here is understood to be 2. Sometimes children write 1. My base is 3. Here's my exponent. So exponent over index, EI, would be 5/2. All right, time for you to do an assignment.